Just take a look around you. I mean, really look. From the device you're watching this on to the room you're sitting in, there's this secret language of shapes that's holding everything together. So in this explainer, we're going to decode that language. We're going to turn what feels like complicated geometry into some really simple, powerful tools that you'll start seeing absolutely everywhere. Okay, so what could an ancient pyramid, a brand new bridge, and a slice of pizza possibly have in common? I know, it sounds like a weird riddle, right? But the answer is actually this powerful, unifying secret. There's a hidden thread that gives every single one of them their shape and their incredible strength. Any guesses? You guessed it. The answer is the triangle. Yeah, I know it probably just seems like some simple shape you drew back in school. But trust me, it's the real hero of our story today. It is, without a doubt, the fundamental building block of our world. And to really get it, we're going to meet the key members of its family. We've got the super reliable right-angled, the perfect equilateral, and the balanced isosceles. Oh, and a pretty special hybrid case, too. By the end of this, you're going to have a brand new geometric toolkit. So let's dive in. Okay, first up, let's talk about the workhorse of the family, the right-angled triangle. You should really think of this one as the cornerstone. It's the foundation that so much of our designed and engineered world is literally built on. See that little square in the corner? That's its signature mark. It's the universal sign for a perfect 90-degree angle. And this isn't just some random symbol. It's the key that unlocks a whole world of powerful geometric rules. It's what gives this triangle its amazing strength and stability in everything from skyscrapers to your kitchen table. Now, we've got to talk about one of its most important features, the hypotenuse. It sounds like a complicated word, but it's not. It's just the side that's opposite the right angle. And here's the kicker. It's always the longest one. Getting a handle on this one side is absolutely crucial because it's the key that unlocks all the powerful math that makes this triangle so incredibly useful. And right here, this is where the magic really happens. I mean, look how simple these tools are. The area is just half the base times the height. Easy. And if you know the hypotenuse and one other side, you can always find the missing one. Now, these aren't just formulas for a math test. These are the exact tools that carpenters and engineers use every single day to build our world with perfect precision. All right, next up, let's meet the perfectionist of the triangle family, the equilateral triangle. You know, if the right-angled one is the workhorse, this one's more like the artist, where everything is just in perfect symmetry and balance. You can almost feel the harmony just by looking at it, can't you? Every single side is the exact same length, and every angle is precisely 60 degrees. This perfect symmetry isn't just nice to look at. It means that stress is distributed perfectly evenly across the shape, which makes it incredibly stable. You see this pattern all over in nature, from snowflakes to mineral crystals. And this is where its simplicity is just brilliant. Because of that perfect symmetry, every single calculation, from its perimeter to its area and even its height, all comes from just one measurement, the length of a single side, which we'll just call A. It's a really beautiful example of how elegant and efficient geometry can be. You just need one piece of info and you unlock everything else. Okay, now it's time to meet the isosceles triangle. So if the equilateral is all about perfect all-around symmetry, this one is more of a specialist. It finds its balance in a different, more specific kind of way. So its defining feature is that two of its sides, its legs, if you will, are exactly the same length. The third side, the base, is different. And this one feature has a direct consequence. The two angles down at its base are always equal to each other. It creates this perfect mirror image symmetry right down the middle. Now, this unique structure completely changes how we do the math. We now have two different measurements to play with. We have A for the two equal sides and B for the base. So its perimeter becomes 2 times A plus B. It's a super clear example of how the geometry of a shape directly tells us what kind of math we need to use to describe it. So, we've met the foundational workhorse and the balanced specialist. But what happens when you combine their best features? I mean, what if you could take the raw strength of the right-angled triangle and fuse it with the symmetry of the isosceles? Well, you get a seriously powerful and incredibly useful hybrid. Let's imagine for a second that we're in some kind of geometry lab. In one beaker, we've got the pure, unshakable strength of that 90-degree angle. In the other, we've got the perfect balance of two equal sides from the isosceles. We pour them together, and what do we get? This. This is what we get, the white isosceles triangle. It inherits that 90-degree angle from one parent and the two equal sides from the other. And that unique combination forces the other two angles to be a perfect 45 degrees each. It's a really elegant and efficient shape that, I promise, you'll now start spotting everywhere, especially in things like tiling and roof construction. And because its properties are so fixed and predictable, the math becomes incredibly simple again. The area is just half of that equal sides squared, and the hypotenuse, well, it always has this direct, simple relationship to that side. This makes it a total go-to tool for designers and engineers who need fast, reliable calculations on the fly. So after our little journey through the triangle family, we've pretty much assembled your toolkit. And these aren't just shapes, they're actually lenses that you can use to see and understand the world in a completely new way. So let's do a quick recap of our four heroes. We've got the right-angled, our unshakable foundation; the equilateral, the ideal of perfect balance; the isosceles, our adaptable specialist; and finally, the right isosceles, the efficient and powerful hybrid. Each one plays a really critical role in the world all around us. Now that you can recognize these fundamental building blocks, your whole perspective is going to change. The next time you look at a skyscraper or a bridge, or even something as simple as a bicycle frame, you won't just see the surface. You'll actually see the invisible network of triangles that's giving it all its strength and form. You'll see the hidden geometric skeleton holding it all together. So we've given you the geometric toolkit. The only question left is, as you go out into the world, what will you see differently?